Okay. Sorry for the delay, my presentation was stuck. I was not able to launch it. So, hello everybody again. This talk is about OASIS. It's a tool that I've used for over 2 years now on different projects. So I plan to keep some time at the end of the demonstration for questions and demonstration. So let's go. So how it started? It started in July 2008 with a simple prototype and some pieces of code gathered from 3 different projects. I presented a small prototype on the IRC channel, and at the same time I was doing some blog posts about Debian problems, and especially Debian packaging problems for OCaml applications and libraries. And it was quite enlightening to be able to make a simple summary of the most common Debian packaging problems for OCaml in Debian. So with my prototype, in fact, Mauricio Fernandez replied with a more simple prototype using Cabal concepts. We will talk about Cabal after. And I read it, and it was really, really smart, and I wish I could use it. So I started the project, and since then, I added new features to OASIS. Every time I integrate a new project with it. And since 4 months now, I renamed the project from OCamlAutobuild, which was its initial name, to OASIS on the Camel Consortium proposal, because it was more clear and more simple. So, and last week I do my first public release. Maybe some of you have already downloaded it and tried it, so I hope they enjoy it, and whenever you have a problem, just come back to me. So, here is a very short summary of the most common packaging problem for OCaml applications. So, non-native architecture. The first point, most of developers use AMD64 or x86 to develop their application where OCaml opt is available. So when they try to do some makefile to be able to install their application on non-native architecture, they just can guess how to do it, and unfortunately most of the time it's not a good guess. There's good solution to do it, but when you cannot try, you still have problem at the end. The other point is not using OCaml Find for libraries. So FindLib, which has been developed by Gert for over 10 years, I think, is a very good solution. And in Debian, we promote this solution because we think it's really easy to use libraries through OCaml Find. And for beginners, it's a must-have because it just removes a lot of black magic from the command line invocation when using OCaml Find. And the last point is a custom build system. Well, custom build system is not a real problem. I mean, we can live with it. And especially if everything is okay. I mean, if it compiles, if you don't have any problems with non-native architectures, and if the libraries get installed on the right place on the file system, there's no problem with a custom build system. But whenever we need to fix something in the build system and we don't know how it works, we need to understand the scheme of the makefile, the scheme of the OCaml build build system or anything like that, and to fix it, it takes longer. We try to avoid it. When I talk about custom build system, I'm not talking about OMake, OCamlAutobuild, or OCaml Makefile, which are quite common build systems. Okay, so the requirements of the project. So we need at least the 3 steps, which are configure, build, and install. This is a very common step for GNU enabled project. And so for the check step, we just check the build environments, enable or disable features, and then we can run the build step, which is about to create libraries and executables, and then the install step, which is about moving results of the build step in the right place on the file system. So what we can use for the project? We can use OCaml as a scripting language. After all, we are targeting OCaml enable system. So we know that we will have OCaml at hand when trying to compile the project. And OCaml as a scripting language is quite effective. So we will use OCaml find and findlib to detect libraries and their version. We also can use OCaml build, OMake, and OCaml Makefile, which are standard build system and which just work. What we should avoid at all costs, of course, shell script and Unix command. The point is that whenever you run a shell script, you make a dependency on Cygwin for Windows application, for Windows installation. And it's quite heavy. I mean, most of the Windows user don't have Cygwin at hand, and they don't want to install it. We want to avoid adding dependency to your project when you use OASIS on your project. So we must create something self-contained. We don't want to force project to change things that work, because, as you know, if it works, don't fix it. So we should provide a way to continue using the good old scheme to install, to build, or to configure things. And of course, we should avoid reinventing the wheel, which implies to be able to use external libraries to do something. So, Cabal. What is Cabal? Cabal is a packaging and building system for Haskell. It's quite effective. It's a building block of Hackage. Maybe some of you know what is Hackage. It's a C pane for Haskell. It's really easy to use external libraries through Cabal because it's just a line of text in a text file. It is based on a single text file, package.cabal. It's really easy to read, easy to write, and it's probably, to my mind, one of the reasons of the success of Haskell in the recent years. So, let's copy it. Here is the OASIS file, and in fact, we copy almost everything from the Cabal file format. So, we've got fields, which are simple key value separated by a colon. We've got sections, which are this kind of thing, library and executable. The body of the section is just indented. We've got freeform. So freeform, you've got an example here. It's when the value continue on the next line. You just mark continuation using indentation. And you've got conditional. It's not here, but it's about setting specific fields to values using environment variable and flags, because you can also create flags in the file. As you see, it's a simple text format. It's easy to read, it's easy to write, and to my mind, beginners can understand it and write it their own. So basically what we do, it's just about compiling this text file into a build system. So setup.ml is the main entry point of the build system we will create. And we will use plugins to compile subsystems like build and install and other things. So whenever you want something new, you just create a plugin and you can translate the install part, for example, by just translating the _OASIS file into something new. We will use external commands when standard lib is not enough, so we don't put new dependency. For example, OCaml find, OCaml see, and cp-rm in an OS dependent way. We also can use external libraries. For example, OCaml graph is used, but only at compile time. In fact, we just dump the result in the generated build system. So, how it works graphically. Everything starts with _OASIS file. Then we run the OASIS tool on it, and we generate many files in your source code. So the main entry point is here, it's setup.ml, but we can generate other files like this one or this one, which are typical files for OCaml build. We then run the configure step. The configure step generates a setup.data, which is basically make file containing key and values separated by an equal sign. It's very basic. We then run the build step, which in turn generates a setup.log, which contains what has been built during the build step. We can optionally run test and doc and other targets that I won't describe here. And we can, using the setup.log, we know what has been built and where it has been built. So we just have to install what has been built. So it's quite effective, and it helps to detect if we have compiled, for example, .cmxa or not. And we can also run an uninstall target just after it, because we know what has been installed through setup.log and everything like that. So a beginner can just customize _OASIS. You can do a lot of things just customizing this file. It's very easy. But an advanced user can customize almost any generated file in the source code. In fact, all generated files follow the same scheme how we generate it. So you've got an header and a footer where you can put whatever you want. It will be kept every time we rebuild the thing. We just replace a section in the file, in the generated file. So, is it working well? I think it scales from small libraries to quite big application. For example, OASIS itself contains 3 different libraries and 3 different executables which are interdependent, and we can compile it. We can compile it using OASIS itself, so it's kind of bootstrap, and we are able to describe everything. There's a little bit of customization inside, but we can do it. It's easy to extend through plugins. Every time I need something new, I don't try to change everything. I just try to create a new plugin which translates the _OASIS file. The main problem that remains is that it creates a very huge setup.ml. It's around 5,000 lines of code, so it's above 100 kilobytes. I think it's a problem, but when you see a configure script is around the same size, and it's only doing the configure step, and it's deadly slow to run also, but anyway. So, back to the Debian problems. Well, the first point, non-native architecture is a basic feature of OASIS. The fact that we are not using OCaml find for libraries is also a basic feature provided by OASIS, but we also, I write also something, a plugin called Meta. So the plugin Meta, in fact, reads the _OASIS file, parse its depends, build depends, and everything like that, and just put it in a meta file generated with the right version, the right build dependencies, and everything needed. Most of the time when I try to, there's almost no customization for doing a meta file using the plugin Meta. It's almost automatic. Not every case is is okay, but most of the cases I tried are okay. And the custom build system, of course, setup.ml for now is only used by 3 public projects, so it's remain for now a custom build system, but I hope that if it's widely adopted, we will get a chance that it leaves the custom fields and enters the standard even. So, what about future projects? So it's basic idea I had. I don't say that I will implement everything, but I will try to because I think it's useful. OASIS self-contained, for example. Since in _OASIS, you know every depends of your package, you can fetch other depends and just build it in seconds. Just create a tarball containing everything and build in seconds. It's not yet created, of course, but it can be something interesting. OASIS checkout, there's VCS information in the _OASIS file. So we've got a kind of the same kind of thing for Debian, which is called deb checkout, and it can be useful to just check out the version of the package you are working on. And my last point is bookage.okamlcore.org, which I hope will be the package for OCaml in OCaml. Using this _OASIS file, we can get a lot of metadata about the package and translate it to web pages, and I hope also that we'll be able to translate it to GODI, because I take inspiration of Godiva, and I hope it will be enough. So, as a conclusion, there's still a lot of work to do. For example, the OMake and OCaml Makefile plugin is not here for now. I'm working on it. What you get when you use OASIS is that you get something which is quite portable and standard, and you get a full build system with the configure, build, and install step, and additionally need test, doc, and uninstall step. It makes life easier for Debian packagers, for example, because metadata can be used to synchronize with. In fact, it shows what your build depends are, so it helps Debian packagers to write their own build depends for the package. At least it helps me. And I hope that it will be a building brick for package in OCaml. Okay, let's have a small demonstration. On the side, okay. Try it. Yes, yes.
Ah, yes, but better. No, he likes his eyes.
Okay, it's okay. So, for this demonstration, I will use the current version. Yes? Okay, yes. Can you hear me? Okay. Can you hear me? Okay. So I will have to work with one hand. OASIS.sh. Okay, I will use OASIS in quick start mode. Quick start is an helper to generate your _OASIS file. Okay, so it asks basic question. I will answer it quickly. So, meeting package 0.1 synopsis demonstration. Author me. License. So the license, you see I write LGPL 2.1 or over, LGPL 2.1 plus. DEP5? Yes, Debian enhancement proposal with OCaml linking exception, exactly DEP5. Create a section, so I will create a library, no, an executable, and name of it hello, and I set the path to source hello. The main is main.ml, create another section? No. So I will add some extra things because I like to have a makefile. I will ask in the plugins to run the dev files plugins, which will create my makefile, and I will use OASIS in dev mode. It means that every time I change something, I will automatically rebuild everything in the generated file. Okay, that's it. I can run make now, and as you see, okay, you see the first part here is the configure step. We have detected everything that we need in about less than a second, and then I just run the build command using this command, which is OCaml build source hello main byte, and rename the target file. So I will just do something, just one extra thing. I will run a test. So I will create the test, executable test, path test, and main is test. As a matter of fact, this test need to depend on all units. So I add a build depends on all units. And I will run it through a test section. And I just have to tell the command. And the command is $test, because $test will be expanded to the name of the executable, whatever it is. So verbose. That's okay. So since I'm running in dev mode, I don't have to call again OCaml build, it will be automatic. So I hope that everything is okay. Okay, I just run the build step, so now I run the test step, make test, and you see, okay, no implementation for test of section main. Ooh. Okay, it's not working. Test main. Yes, okay. That's because I don't explain the type, so it's custom, because I will run a custom command. Okay, again. Okay, this time it was okay. You see here, I call the test with the verbose. The $test get expanded to the right name of the executable, and I just run it if it's all unit standard output. Okay, and of course I can set version to say that I want a specific version of all unit for the configure step in the build depends. Okay, that's all. Any question?
Thank you, first of all.
Thank you. Thank you for listening. Sorry. Okay.
Questions?
Zach is asking
Oh,
a
sorry.
So I actually have two. So the first one is if you fix a syntax and semantics for versions, which is potentially very painful because you need, I guess the OASIS tool need to check for version, something like that.
Yes.
So, and I know that in Cabal they declare dependency and the kind of stuff. So if you fix the syntax and semantics for that. And the second question is whether it will be possible, in your opinion, to have a tool that out of this generates automatically a Debian package like the OCaml guys do.
Okay. So first question, the semantic about version is just the semantic we have in Debian. So we just put relation about the version of it, and that's all. So
version comparison is in the Debian semantic.
Yes, exactly the Debian semantic, and we have and or.
That guy be happy about that?
He's asking a question next.
Okay, and second question, can we build a Debian package out of it automatically? I don't think so, but we can synchronize it. I mean, we can do, I think, 80% of Debian packaging using a simple command, but we still need to do some customization, probably do some customization, but I think we can almost generate everything. But then we have to, like a dhmake, you can do almost everything, but then you have to fix some points. This tool is not about covering 100% of your need. It's really not about it. It's about covering 80% of your need and giving you the chance to be able to fulfill your own need at the end. That's just my point. I don't try to fix every case that exists.
I mean, actually, my question has been answered. Cabal to spec is a program that Haskell guys use to generate spec files. I was wondering, you've already answered it, but I was wondering if there was going to be an OASIS to spec to generate RPM spec files.
Can you repeat, please?
Cabal to spec is an
Okay,
RPM.
Cabal to spec. Okay. Yes, we can do also for spec files that I think we can generate almost everything, but you still need to have some fix to do around.
Yes, when you did the executable test, you had to specify the dependencies manually.
Yes.
But for example, if I'm using OCamlAutobuild, then it does that for me automatically, so I don't want to use that.
No, on external packages, there's nothing.
Okay, it's dependency on external packages.
Yes, of course.
It's not internal to your own.
Well, not exactly, because you can have internal dependencies among dependent packages. So, for example, if you are building two libraries and the first one depends on the first, the second one depends on the first, you will need to set a build depends here. But the point is that it also helps you to create the meta file. And for certain build system, it is required. OCamlAutobuild does it almost automatically, but not every build system does it automatically. I mean, to generate the interdependent packages. And we also use it to order our build of libraries, for example. So we know which library to build first.
I just have this is just a comment about the name of the file. Usually for me, underscore means that you can ignore or remove, like the build
Yes.
directory of OCamlAutobuild.
Yes,
So
or
I
underscore darks, you mean?
Yeah. Or,
Try to remove it.
No, but I mean, if you want to make
No,
a distribution.
if you want to know why this name, in fact, it's because it's Windows portable. That's all.
Yeah, but I mean, you can also have called it OASIS.package.
OASIS.package, yes, I can call it also that.
It's just a comment.
Okay.
More questions?
Oh yes, Mehdi just tell me that it's available in French and in English, and if anyone of you want to translate it to German or anything else, there's a PO file that you can translate using standard tool for getText. Okay, so thank you for listening.